for staying. This will be code-heavy talk. Is it a talk? It's a walkthrough. The purpose of it is to show that what usually being understood under dependency injection is usually it's correct, it's in the right direction, but people stop or like in iOS community we don't have enough of examples how to properly control lifetimes of objects, how to inherit scopes. Compared even, for example, to Android, where they have Jagger, which has some components, and we have nothing of that. So I will be walking you through an app. We'll build a small app which contains all the things we need to showcase the problems and the solutions. So the app will consist of 4 view controllers, A, B, C, and D. Like in a good prose, every view controller will have its own very specific role to showcase problems. So a view controller is our unauthenticated scope or authenticated state. So its role will be to first authenticate us, log in, and get some session. You can think tokens. I think most of you are doing nowadays, or either OAuth or some kind of token-based authentication. So, and you know that what you can do when you're logged out and logged in is drastically different. So the B view controller is the first view controller who depends on us being logged in, and it uses store to save some kind of information. The trick here is that store is user-based or session-based. So it depends on the session which appears at runtime.
Is this implicitly some kind of Redux thing?
No.
Okay.
It's pure Swift code. Yeah, no connotation, think repository. C view controller is for just being there. It doesn't do anything. It's like intermediate step which is not interested in anything but lives in this logged in scope. And D wants to read from this repository based on session. So let's go to the code. So this is like a basic setup to continue working on. So here are 4 view controllers. There is no storyboard or exit, so I create a navigation controller, put my first A view controller inside of it, and make it true. So everything is straightforward here. And what those view controllers at the moment do is that they just allow to press a button, go to another view controller, and they do this in very familiar to everyone way by instantiating a view controller. Because I'm not using the zip, so I'm directly instantiating it. And I'm doing all my UI work in code. And there isn't much. So this is how it looks like, trivial. So let's first implement what I showed you. So we have to authenticate, we want to save state, we want to read the state on the last view controller. And let's do it first in this kind of like a bit short-sighted, naive way, but which allows us to like move really fast, where features are like immediately implemented, and when someone asks you how long will it take to implement, you're saying like half an hour. So let's get cranking. Let's introduce.
I didn't leave work earlier to come to more work. You can.
Let's introduce auth gateway. So this is the thing which is, for convenience sake, is synchronous. Of course, authentication is asynchronous thing. So this authentication gateway, when asked, will give us some fake session to work with. Let's add more. Let's actually start using it. Let's go to the A view controller, which should be doing this, getting the session, logging in. So what we do is that we simulate authentication, we authenticate, and before going to the B, we should now decide what we do with the session. And what we'll do is that we will very conveniently store our session which appeared at runtime. We will store it in a global scope. And how we'll do it, we will use static property. So this thing, I've seen this in the wild, so this is not purely artificial construction. So it's a struct with a static property and it's mutable, so everyone can save session there and read from it. Well, you can think whatever you want about this, but it's convenient.
It's a singleton.
It's kind of single, yeah. I could have created.
Kind of. It is.
Yes, I could have created some kind of repository, created a singleton for it, and put there the session and just simplified it. Right? We need features, by the way. Yesterday. So what we do now is let's introduce store. Store will be saying where we will be saving our state, and the store it depends on the session. So there are only two ways we can do this. We either initialize store with session, or we pass session on every operation on the store. So I choose the latter because it allows me to create a singleton store. So a session should be passed every time I use it, and B does that. First glimpse of upcoming problems, because we never know if session is there. I have to do the unwrapping and do the check, but who's this stuff there? So we do the saving, and let's finally add the reading. And in the D, we using basically the same unwrapping pattern, we read from the store. So let's quickly look how it looks like. So singletons everywhere, as we quite used to in iOS community. I'm saving some state. Here I retrieved it. It works. Almost everyone who uses the app is now happy because on outside there is nothing wrong with this app. It's done according to the specification. What kind of problems there might be? So small apps and even medium-sized apps are beautiful because you can do whatever you want, and it's hard to mess this up. It will work. You'll find a way to cut corners or do something like to make it work. So, but the more you will continue working on this app, the more people you will have. You will start realizing that when you're using singletons, it's really hard to kind of stop those side effects for tests. So testing becomes a bit hard. You have to figure out what to do with that. There is also no compile time guarantee at the moment. So when we're retrieving session, it might be not there, and we will have to handle this case. Usually we do some kind of fatal error or like going back to the logged out state. And one less obvious thing is that we can't quite easily modularize this code. If you would try to put A, B, C, and D into different feature modules, you would realize you're depending on those singletons, you're depending on the scope defined and app delegate, you have to refactor, forget it. So let's start, let's go the path where we decided to modularize it. Let's start kind of fixing this, making this more scalable code. So first what we can improve immediately is just pass session around instead of storing in the singleton. So we remove it, we change the view controller to take session in, and we pass it through the B, we pass it to the C because we finally need it in the D. And it gets to the D, we're no longer unwrapping anything, we're reading it directly, or passing it directly to the store. I hope you still follow, because even if you feel like this is obvious or familiar, it will get much more interesting. So one observation we can already make, that our C, which is not interested in any session or store, is now forced to have session. So it's now part of dependency resolution mechanics, accidentally or not. But let's close our eyes on this for the moment. We can improve this code a little bit more. We can get rid of singleton store because we can now initialize store when we get session and pass the store around. Let's do that. So store has changed. Now store is initialized with session. Right here. Luckily, API no longer depends on passing in session, which is
A view controller not only gets session, but also initializes store, passes to the B, C, and D. Nothing has, like, on outside app still works the same. There is still a problem with C. It's still not quite testable because we're creating instances on our own. And it's called control freak incentive pattern when you're creating instances on your own. Let's improve it a bit even more. So what we can do is first stop creating off gateway ourselves. So we pass it to the AV controller. So we are now using constructor injection to the full. This is where usually kind of some articles stop. They can say, well, use constructor injection, just inject all your dependencies and you will be golden. You will be able to test all of this. Well, they usually never mention pass-through dependencies like this, which involved in the dependency resolution mechanics. Although they mention protocols, so we should do that. And one thing is that A view controller knows about B view controller because it directly initializes it. So let's fix this first. Let's do something about this. How do we fix, by the way, those kind of things? Because up to this point, we were just passing something through to the next node every time we needed it, but this time we cannot, like with our authentication gateway, pre-initialize A view controller with B view controller because it depends on some runtime thing. This is where scarily named pattern helps us, called abstract factory, because it moved enterprise. Oh my god. Factory. So factory will help us because factory acts as a kind of like a promise, sort of a, I promise you to return what you need, given you will supply me what I need. And we erase the knowledge that it will be a B view controller. That's one small wing here. So who implements this factory? Well, A view controller is the first one, so unfortunately delegate has to do all of this. So I created this small structure called container. Why I called it this way will become obvious later. Currently it just implements this protocol and is capable of creating our initial view controller with gateway and then creating B, and the factory for B is this container. I hope you're still following this, so because it will become more and more complex. So we are currently solving the problem of where we get dependencies from in the A view controller. So let's apply the same pattern for the rest of the view controllers. So now we have factories in every view controller. So B creates C through indirection and all the way to the D. Why we need this? If you're already not sure why we're doing this. In the future, this will help us to put them into different modules and make them independent of each other, unknowledgeable of each other. Why it's useful? Compilation times, but we'll get to that. So, we are really close to having perfect constructor injection dependency injection based on constructor injection. So one last thing is that our store and authentication gateway are still classes and we use them directly, but we want to inject protocols, right? Because we will substitute them for test doubles during test time. So here we are. We are creating particular instance of default auth gateway, injecting into the A view controller, returning it. When we ask for B, in a given session, we create first default store, particular instance, inject into the B, and return it. And of course, A only knows about the protocol, B only knows about the protocol. So what we've done, we made our consumers, which accidentally in this case view controllers, they may be view models or something like this. They made them unaware of any particular instances. They are no longer creating them, so we can stop all the side effects of them, including creation of the next view controller, usage of the store and gateway, and start with some brick-hand answers and test them without side effects. And this is good. This is quite good already. We only have one small problem. Is that C is still involved in this dependency resolution mechanics, and we pass store through it. This might be another problem in this such a small app, but when you have app with hundreds of view controllers or whatever your node is, router, coordinators, and if you will be doing dependency resolution mechanics in your feature code, you will get constructors with, I don't know, 10 maybe parameters, even more. So we want to solve this problem. We don't want to make our feature code depend on things which it's not interested in. It also hinders our compilation times. So let's start thinking, how can we solve this? But let's do a few permutations at first. Let's take this large container thing, which is factory implementation for every factory protocol, and split it into separate containers. All nice and cozy, straightforward. When we ask create A, we create a new view controller, we create a new B container as factory implementation. I hope you still follow. Because I know, I really want you to prepare, because now it will become more much harder.
Are you saying we're getting to the good stuff?
We're getting to the good stuff. We're getting to the scope inheritance.
Like we're not using the app delegate?
We are no longer using app delegates mostly directly. We're only creating container first and asking for the role of app delegate. The containers are separate. So the good stuff. Let's do one not obvious change to our containers. Well, there is a small problem here. Currently, containers are just nothing more than a direct implementation of a factory. They don't contain anything, right? They're containers, but they're not containing anything. Everything is kind of like who owns our dependencies? Who owns the store? Who owns the gateway? View controllers.
We do.
Coordinators.
Yeah. So let's change this. Let's delay creation of this container. So how can we delay it? If A will become a B factory on its own, how it will look like? Look like this. Functionally, nothing has changed. I just reshuffled code. So A container is now itself a B factory, so passes itself. When it's asked to create a B, first it creates a container, and then only creates a B view controller. So now you can, I think some of you can already see something which becomes possible here. So we can now move this session part, right, from here to the container first. So, but let's start from the other end. Let's go to the problem. The problem is that B is enforcing on C the dependency of store, but there is already store, and theoretically we could receive it somehow from the existing authenticated scope, because it's already there, it was already created for B. So let's remove this. Let's no longer force C to own the store and be involved in dependency resolution mechanics. Move it here. We just create pure C like it should be. We should have store, no store. Store for you, we're not using it. Store here. No store here.
D is not using the store.
D is using,
Okay.
but C has no knowledge of that.
Ah, so you cannot pass it.
Yeah, it cannot pass it. Yeah, C is not interested in the store and should be involved in this resolution mechanics. So let's go back to the app delegate and remove some of the things we no longer need. So when we make D, we no longer pass store, no longer take in store. When C is created, we no longer take store. Need store here. Need store here. In the end, after all this permutation, we should have only one error. Let's see if we will get only one error. Quickly check all my protocols. Bit.
Where it says make signal.
Need this. Accidentally removed this section. We need this. We still need this, unfortunately. Cool, one error. So what's this error is? Here, we need store. We should get it from somewhere. Well, let's reason about this. Where we have stored appearing first time? Well, somewhere here, when we create B. And B is a container, right? So let's make the right thing. Let's make the container contain its dependencies. Or in other words, let's make it bound dependencies on the B scope. And the B scope is our authenticated scope. So what we want to do is this. Make B container take session. So it will have, well, let's immediately write needed session. And voila, this is our store. It will live now here and only here. We can create it. Session. Cool. Let's run this. We no longer need to be passed here. So far so good. We haven't fixed the problem, but we kind of reshuffled again the things. So now store is much closer to us because it's now bound in the B container. The only mechanics we need is just to get it somehow. Well, we can go like more straightforwardly. We can just use the store, and then we are creating other containers, just pass it here, right? Again, use the same mechanics, just passing down the line. It will work, but if you will have like many dependencies bound on some scope, it would be daunting to write all those passing through. We need some better dependency resolution mechanics. We need tree traversal. We want to traverse upwards. So let's do this. First, what we want to do is, given the store, so now when we create B, we would say, and we're creating in the B, we create store, and when we're creating C, so we would now say, I will be your parent. What? I will be your parent. And the C will get as a parent B container. This already allows the C to get the store, actually. For example, here. Right? We're nearby, but C doesn't need store. Let's continue this. Let's say when I'm creating D, I will be your parent. D will be the parent of C container. Now, we can do the traversal. Store is parent. Parent is our B container, and here's the store. See, I haven't missed anything. Same app, works the same. Cool. So what have happened? If you haven't quite followed, we completely changed our dependency resolution mechanics. We shifted completely away from the feature code or our view controllers to the shell, and the shell in this case is our app. In this approach, your app, you look at the app as just a shell which assembles things together, and you move all your code in the libraries or dynamic frameworks. Why? Because in large apps, compilation times is the problem. It gets like, it's first at like minute, 2 minutes, 5 minutes. Clean build's getting 10 minutes. Why? Because if it's a large monolith, you cannot parallelize compilation. In order to parallelize, you want to have modules with as less dependencies as possible so they can be compiled in parallel, improving our compilation times drastically. And this technique, where we move all dependency resolution to the shell, allows for such modules. So let me quickly show you how the final, nothing changing in the functionality. I will just put everything into modules just to show you. So I now put things in the respective static libraries. So here is our A view controller. Let's see what it depends on. It depends on module providing authentication. Logical. It doesn't depend on the store. Base UI, we need just to add the button. Let's see at B. Well, B depends only on the store, no off here. What C depends on? Yeah, nothing. It depends nothing. It knows nothing about the store, it depends nothing about off. So it can start compiling faster and earlier. And what about our containers? Well, I took the liberty and just put it in every container in its own file. So the app itself contains nothing more than our containers or dependency resolution mechanics. And it works. So that would be it, but I guess some of you might have missed like the core mechanics of how we inherit scope. So I want to show you how it looks like on the diagrams. So imagine the white thing being our shell, our app delegate, our app, and the black thing is our modules. So a view controller living in some kind of a module. It has a respective container in the shell, and container is responsible for creating a view controller. So view controller, being in a isolated model module, defines its own factor, its own perceived view how its dependency should be created. Its next some kind of B view controller should be created. And a container becomes the implementation of this factory. When A asks B factory, what happens is that a container goes and creates another container, which in turn it will ask to create the final B view controller. And when we create this container, we pass the reference to ourselves, to the A, so that B can do the lookup in the of dependencies bound in a container. Usually we learn that we shouldn't be doing this child-parent relationship. Usually it's like parent knowing about the child and the child's knowledge of the parent is in the shell to have all the knowledge, because this is the place where we can connect things together, and this becomes our app. So, and this pattern continues. What's interesting, one slight addition I want to tell you is that you don't necessarily have to make linear parent inheritance. You can, for example, say, I don't want to know anything about C, I don't depend on the C scope, so I can just bypass it and let D directly be the parent of B container. That's also possible. So this is like idea behind the framework called Dagger on Java Android side of things. And why it's called Dagger actually? Because it's a directed acyclic graph. meaning that it can skip certain nodes as we do here. It's directed, it's one directional, we're always going to the respective of you to the right side, but we can skip certain nodes and don't have to directly depend on them. So what we did actually, we did sort of manually implemented what Dagger does with subcomponents when it generates code based on the annotations. So there are two key properties here which are really important. If some of you think, oh, sounds complicated, I can do better. It's great if you can do better. Find me and let me know how you do it. If you can still maintain two key properties, it should be compile time guaranteed. So if it compiles, it will resolve successfully at runtime. So no optionals. And you should not have any pass-through dependencies, meaning you should feature code which doesn't use something, shouldn't depend on it just for the sake of dependency resolution mechanics. And that's it. You can find this code on my GitHub, and you can walk through every step if you haven't understood something. And questions?
I have one.
What number did your mic set?
Sorry.
What number?
3.
Yes, questions.
Yeah. If you please go back where you said parent.parent.self, isn't that, so if you go in the last container, so isn't that a little bit fragile code that you are parsing parent, that the D container have a knowledge of the previous containers and how many nodes you need to parse it up?
Fragile in the sense that if you would reshuffle things, it
Yes.
won't compile.
Yes.
This is the essence of this.
Right.
It's fragile by design. If it doesn't compile, it means you cannot do safely dependency resolution.
And is it ambiguous, like a parent.parent, or is it just naming it meaningful to make it more sense?
I don't quite understand.
Would changing the names make it more meaningful for you?
Yeah, like it says parent.parent.store. So
You can do in every container, for example, re-expose some dependencies to remove this kind of parent logic. But you would write more code. If you feel you don't like name, you can rename it. As far as you understand the mechanics behind this, you can do anything. You can add here only that, yes, you might get parent, that parent, that parent, that parent, that parent in large apps. The next step would be, and this would be really where you really advanced that far, is to introduce some code generation. I know of two libraries that are capable of doing this. One is by Uber, because they understand the same mechanics. It's called Needle. I think it's like hello to Dagger. And another one was released just recently. I don't remember the name, unfortunately. It uses basic annotations in comments. You just do a lot of comments, and it's capable of generating something similar. So you wouldn't write this. But introducing this should be done only in very large apps where it's just too tedious to manually kind of maintain it. Because code generation introduces even more indirection.
thank you.
Great talk.
Thank you.
So D in this case has sort of an implicit dependency on C, you could say, because it's getting its parent. Like, how does it work if you want X to present D? Like, can you?
I understand the question. So let's split this question in two, right? So there is D as a view controller, which is completely oblivious to anything. And there is a D container. So D container has nothing to do with D view controller specifically. It was created only for the purpose of capturing scope. So if you will be, for example, navigating from X to the D, and the retrieval should be done differently, then you would probably have some other container for this case, like XD container. or something like this. What would you rather, or more highly likely would do, and this was in practice, you would probably find more useful this approach where you realize that D is interested in the B, C is interested in the B, X is interested in the dependencies bound on the B scope, and you just make them all depend on the B by passing some intermediate nodes which have no value for you. Is that the answer, or?
So you couldn't take D as it stands and put it in another flow.
D, which D? The view controller or the container?
Well, both really.
View controller, you can use it everywhere. It's oblivious. It knows nothing. It's just, it only has constructor which says, give me store. Whoever created it and gave it store, it's fine.
Yeah.
This part is actually captures your flow, your app flow. So whatever your flow is, it will reflect it,
Yeah.
or the scopes of it.
So I guess I'd ask the question is, why doesn't D have a protocol that provides defines the store that it requires that B or C conforms to pass the dependency
The
down?
container or?
D container.
Because it's a shell. In the shell, it's thin. It has no logic. Having protocols there have no purpose. It's your like scaffolding. It's where you just assemble things together. You don't want any interaction. You're not testing it, at least in any common way. If you can have global access, you can use global access in shell. It's all good.
Thanks for the talk. Question about the same thing, pretty much. So, you wanted to make C independent of the store and abstracted it to the parent, but then C depends on the type, which depends on the store. So it doesn't really make it independent on the store. It just hides the store one level below
C as a container or a view controller?
as a container.
So again, C container, it depends
on the
directly
parent.
for the parent. Yes.
Which depends on the store anyway.
Yes. So this is the essence of design. C is part of scaffolding, which is involved in building your app structure, like a shadow of your actual app. It has to know about its parent because you've connected, let's start this from other end. You have a sorted number of modules, store of A, B, C, and D, as in A view controller, B view controller. And you decide, I'm going to make applicable to it. What the app shape will be. And the app shape will define and will drive your container creation. You will create and connect containers in the way you want to create the flow of that.
Yeah, I understand that. But the only reason to introduce the parent was to hide the store
Okay.
behind it.
So I can address this question from another angle. What we're trying to solve, we're trying to improve compilation times. Shell is the single module. It's okay, if we make C container not dependent on the A container, we won't win with this anything at all. It's still the same executable, one executable. What we want to make independent are feature-packed modules where the meat of the app is in the modules. Shell is just the dependency resolution mechanics. It has no logic. It just creates instances, stores them, passes around, initializes, correct things. So making something here independent of each other has no purpose.
So why did you create the parent? Why didn't we leave the store just as a property of C container and pass it over?
Creating, for example, C container with like this.
Yeah.
Yeah, you can do that. It will be perfectly fine. You will find yourself at some moment in your development cycle that you have that many dependencies, and instead of just using parent to get what you need, by passing through the container all those services, But it's fine, you can do that. It will be still same mechanics basically, just without parent lookup. Thank you.
Great talk, by the way. I've been thinking about this problem. I might have a different solution. What if we use delegates to pass the data and make all the consequent view controllers delegate to be the first view controller that's showing those view controllers? Like the first view controller has the information, and the delegates of the consequent view controllers will be the first one.
Okay, yes. So you will realize that in order to do that, when you're going from the B to the C and then to the D, you have to pass your delegate to the C first.
From the B to the C, you have to pass. Yeah, yeah, that's right. So if we have the B conform to B and C, so B can pass the data to C, which might be nothing.
The purpose of this is not to pass anything in C to make it not know about dependency. It doesn't need to know. So I guess in any reasonable app, you would need a sheer number of dependencies going from B to the D and further on. And if you would be doing passing through the C, you would have to know about them here by importing.
Yeah, you're right. It's the same thing. Using Okay. Thanks.
Great talk. The navigation side, all of these A, B, and C, D modules have a dependency on navigation being explicit, as in pushing or presenting view controllers. Is that an issue that should be abstracted away from those modules as well?
That's a bit of outside the scope of mechanics I'm showing. This mechanics is agnostic to this, right? This would be decision whether to do this or not would be much more opinionated, right? It would
What's
be,
your opinion?
I led the application where we used routers, and I'm not so sure about this anymore. Why? When Apple introduces something new, say pick to preview, right? If some of you did the pick to preview, they know how heavily it depends on the view controller. How APIs are so embedded in the view controller, and you have to communicate and you have to be having access to the view controller. So working around this through the router is possible in a clean way, but it's not fun and it's not adding any value. So I cannot say anything definite. I'm really open to see new approaches, but nowadays I would first start with pushing in the view controller and making view controller in other regards really lightweight. For example, moving all view related work to the view subclass immediately, like large view subclass, move everything there. If you put business logic in some kind of view model or interactor, if you move view logic into the view, you would be left with a few things which Apple wants you to communicate to you through the view controller and do in view controller, like observe certain system states, do the navigation. That's basically it. Yeah. Usually, when people introduce coordinators or routers, they're also solving problem of dependency resolution. They make coordinators instantiate, find and create correct view controllers, somehow resolve their dependencies. When you solve those problems separately, you realize there isn't much to do actually for the view controller.
Thank you very much, Vadim. A round of applause.
Thank you.